Now we are going to do this part of the syllabus 1.2 diffusion. Describe and explain diffusion in terms of kinetic particle theory. Okay, describe and explain. Describe and explain the effect of relative molecular mass on rate of diffusion of gases. We are going to do this part of the syllabus in this video. Okay, first of all, let us find out the likely definition for diffusion. Now, you can see here diffusion is a process by which particles move freely to fill up any available space until evenly distributed throughout. This is a definition from one book prescribed for you. Now, another definition is particles move from a region of high concentration. Therefore, in diffusion, particles move from a region of higher concentration to a region of lower concentration. Okay, until you can add this until evenly distributed throughout. Okay, you can either give this definition or this definition. Now, the rate of diffusion is relatively slower in liquid. Okay, in liquid, the rate of diffusion is relatively slower. For example, you can look in your textbook prescribed for you here. This is a liquid, and here we have a piece of permanganate. The permanganate solid, the particles are leaving the solid and diffusing into the water. So it is a very slow process. Okay. Now, for gases, for example, here we have bromine gas, which is brown. Can you see it is brown? And here it is empty. So we have air inside here. Now we have a glass lid separating these two. Now when we remove the lid, the bromine gas diffuses into the air, into the upper glass gas jar, and air also diffuses down. It's not only bromine gas which is diffusing, air also is diffusing. Okay, but the one which is lighter will diffuse faster, and the one which is heavier will diffuse slower. Okay, so what will happen here? Air will move down and bromine will move up until they are satisfied. In the diagram, how I have explained this, you can see here the small circle here, the small dot, white dot, and here black dot represent bromine and the white dot represent air. When the lid is removed, after some time, they will be evenly distributed. Now, if you count here at anywhere in the space here between the two gas jar, the number of white and black dot will be the same. As I told you, the black dot represent bromine and the white represent air. So we have the same concentration, 1, 2, 3 and 1, 2, 3. Okay, whereas here we have only air particles. Here we have only bromine particle. Can you see that the bromine are more concentrated here? And here they are less concentrated. Okay, and you can see the diagram itself. As it is diffusing, the intensity of the brown color decreases. Okay, here it is more concentrated. Here it is less concentrated until it is evenly distributed. This is diffusion. This is the demonstration of diffusion. Now we are going to see the kinetic particle theory, how it explains diffusion. Heavier gas, we have only we have only free explanation concerning kinetic particle theory explaining diffusion. Okay, so diffusion is explained by kinetic particle theory. Now in your syllabus, you have to explain diffusion in terms of kinetic particle theory. At the beginning, we are just describing diffusion. It is the movement, when you say describe, it is the movement of particles from a region of high concentration to a region of lower concentration. The particles are free to move and occupy all spaces, okay, until they are evenly distributed. This is a description for diffusion. Now, explain the diffusion in terms of kinetic particle theory, why it happens in terms of kinetic. Now, kinetic means energy they possess. Okay, the energy they possess, and this is also the mass of the particle which are diffusing. So it depends on the energy, kinetic energy, and its mass. Okay, we are going to see this in more detail. Heavier particles move more slowly. Heavier particles move more slowly than lighter particle. Okay, at the same temperature. This is very important, at the same temperature. Now we are going to do a demonstration for you. Larger molecules diffuses more slowly. When it is a large molecule, diffuses more slowly than smaller one. So it depends on the mass and the size of the particle. Now the average speed of particles increases with increase in temperature. Now if a gas is diffusing at a lower temperature and then you increase the temperature, the rate of diffusion will be faster. Okay, why? Because when you increase temperature, the particles will gain more kinetic energy. As I told you in your syllabus, it's mentioned, diffusion depends on kinetic energy, kinetic particle theory, kinetic energy, and mass. So when you're increasing temperature, what is increasing? It is the kinetic energy of the particles, so they diffuse faster. Okay, now these three are the kinetic particle theory which explain diffusion. Okay, this is in your syllabus and should know this. Okay, and at the beginning you had the definition for diffusion. Okay, the definition for diffusion, you can mix the two. Okay, now you can also explain if you have to give a diagram, you can use this diagram. Okay, now to better understand diffusion, you can have this also. Okay, has diffusion. If you remove the lid, the gas will diffuse up and air will diffuse down until they are evenly distributed. Okay, this also is interesting. Now we are going to see an experiment. Now, to explain the kinetic particle theory for diffusion, and look at this diagram in your book. This is hydrochloric acid concentrated. So we take a cotton wool. This is a long tube, okay? It is about 50 centimeter cube. It is about 50 centimeter cube, the size of a half meter roll. It is large. The diameter is same as 1 rupee coin, a 1 rupee coin. So it is transparent. This is a glass tube. Now we put a rubber here, a rubber band here, a rubber band here. Now we have taken the cotton wool, we have soaked it in concentrated hydrochloric acid. Then we have put it here. Then we have taken another cotton wool, soaked in ammonia, and we have put them in the tube at the same time. And very quickly we put the two rubber cork. Then we observe. You will see that when ammonia will react with hydrochloric acid, a white solid of ammonium chloride will be formed. And you can see that it is closer to the hydrochloric acid. Why? Because hydrochloric acid is heavier than ammonia. So ammonia diffuses more rapidly than hydrochloric acid. Now we are going to explain this in more detail. Can you observe here? If you can cut this, you can see it is 1 here and it is 2 here. Okay, look here. Okay, this distance, 1, 2, 3. 1, 2, 3. So the distance is 1:2. Okay, 1 upon 3 and 2 upon 3, the distance move. Let us see this in more detail. Now, look here. Here you have a 1 minute. Now, you take that periodic table, you look for hydrogen. You see hydrogen is 1. The figure which is found below is the mass, atomic mass. So it is 1 ammonia, nitrogen is 14. So for NH3, it is 14 for nitrogen, the mass of nitrogen 14, and 1 times 3 is 3. So the total mass, molecular mass is 17. Now for hydrogen chloride, it is for hydrogen it is 1, and for chlorine it is 35.5. Let us see for chlorine. Can you see for chlorine it is 35.5. So 35.5 plus 1 it is 36. This is the molecular mass, the relative molecular mass. Now you can see that ammonia is 17 and hydrochloric acid, hydrogen chloride, sorry, is 36.5. It is about twice. It is about twice the mass. So for hydrogen chloride is about 2 times heavier than ammonia. So you can guess that hydrochloric acid, hydrogen chloride, sorry, will diffuse slower rate and ammonia will diffuse at a faster rate according to the kinetic particle theory of diffusion. Heavier gas move more slowly. Okay. So the white solid is formed here. Now the mass of ammonia is twice smaller than the mass of hydrogen chloride. So ammonia diffuses twice more rapidly, so covering a longer distance along the tube compared to hydrogen chloride. Okay, now we are going to work out more questions in a few seconds. Now let us see this question. An experiment on diffusion of ammonia and hydrogen chloride is carried out in a glass tube. The gases given off by the solution held at each end of the tube. This is in concentrated hydrochloric acid and this is from ammonia. Now, when these two gases meet, they react to produce a white solid ammonium chloride. Okay, which line show where the white solid is formed? Now, as I told you, ammonia is smaller, twice smaller than hydrochloric acid. So it will be in a ratio of 1:2, the distance move. So ammonia will move faster, maybe at A, and hydrogen chloride, that hydrochloric acid is a liquid, okay? But how hydrochloric acid is formed? Hydrogen chloride gas dissolved in water. But the hydrogen chloride gas, which is found on the surface of the cotton wool, will get energy from the surrounding. And when it gets energy from the surrounding, bonds are broken because they vibrate faster. Bonds are broken and they become gas and they start moving. The same thing happened for ammonia. The ammonia molecule, ammonia solution, how it is formed? Ammonia gas dissolves in water to form ammonia solution. So the ammonia molecule from the surface here gain kinetic energy from the air here, from the surrounding. So it vibrates faster from the cotton wool and bonds are broken and it evaporates. Now it diffuses and this also diffuses. Now they cannot meet at B because it is in the middle, see, of these two. So the answer should be A. It should be closer to hydrochloric acid, the cotton wool for hydrochloric acid. Now it will move faster, the ammonia. Okay, now let us see one more question. Now look at this question. Ammonia gas MR17. Here you are given the MR, you see, is a base that changes universal indicator to purple. Hydrogen chloride 36.5 is an acid gas that changes universal indicator red. So ammonia will change the paper, the universal paper to purple, ammonia purple, and hydrogen chloride will change the universal indicator red. You should memorize this. So the figure shows the experiment done on these two gases. After 2 minutes, the universal indicator changed to purple, of course, because ammonia is lighter and has diffused faster. Same temperature because they are on the same tube. Why did the universal indicator change to purple and not red? Because ammonia, being lighter, according to the kinetic particle theory, diffuses more rapidly than hydrogen chloride, which is twice heavier. So the universal indicator changes color into purple because ammonia get contact with the universal indicator first before hydrogen chloride. So this is the. Now in this question, you have two similar tube with the cotton wool soaked in ammonia, cotton wool soaked in hydrochloric acid, universal indicator. Now the question is, in the ammonia tube, the color changes in 34 seconds. The color changes in the universal indicator paper in 34 seconds. Estimate how long it took for the color to change for hydrogen chloride. So you can see that in the previous explanation that ammonia will diffuse faster. So cotton wool would diffuse slower than 34 seconds. So the answer cannot be 34 because they cannot diffuse at the same time. The answer cannot be 100 seconds because hydrogen chloride cannot diffuse faster. The question is how long it took for hydrogen chloride to change the color. It cannot be 50 seconds because 50 seconds is more than 34. So the answer should be 25 seconds. Okay. Now let us see this question. Figure 1.8 show laboratory demonstration for we take ammonia solution here, concentrated hydrochloric acid. Can you guess that so many questions come out in this? Now we have white smoke found here near the hydrochloric acid, and it is longer distance here. About, you can see the size here. It is 1/3. Here the distance is 1/3. Here it is 2/3. Okay, the distance. Now where the gas meets within the seal tube, they react to form a white smoke. White solid form nearer the end of the tube containing hydrochloric acid. Explain why. Now you have three lines. You have to explain these three lines. Why? Because the very first answer is, look at the question. Why the white solid is formed near hydrochloric acid? In your answer, you should not talk about when they combine together they form white solid. It is already given in the answer, in the lead-in. The examiner has already told you that when the gas combine, they form a white smoke. Don't lose time to say when they react to form white solid, all these. Now, what is given in the question is that ammonia and hydrogen got diffuse towards each other. Already use the word diffuse. So we do not explain diffusion. What we have to explain is why it is formed here, why the white solid is formed here. So you have, the first answer should be hydrogen chloride, MR, hydrogen chloride gas, between bracket MR 36.5, diffuses slower, at a slower rate, because it is twice heavier. It is twice heavier than ammonia. MR dissect. Okay, it is hydrogen chloride MR 36.5 diffused at a slower rate because it is twice heavier than ammonia. No, this is why ammonia diffuses at a faster rate, because it is lighter. Okay, I guess that this is the answer. If the distance between the cotton wool of the ball is 45, if this distance is 45, approximately one minute. Now, look at the second part. If the distance between the cotton wool is 45, between the balls is 45, approximately how far along the tube containing ammonia from ammonia will the white ring form? If this is 45, how long will the white ring formed? So let us take, for example, as I told you in your previous video, this ratio will be 2 and this ratio will be 1. Now it is the total ratio is 3. Now for ammonia it is 12.3. Now if you take 12.3 times 45, so the answer should be 30 centimeter. So it is 30 centimeter. It is 12.3. Now look at this question now. The table show all these gases, okay, with their relative molecular mass. Now some question are asked here. List four gases order of the rate of diffusion quickest first. Four gases. Quickest first. So hydrogen will be quickest. Then hydrogen will be greater than CH4, greater than O2, and greater than 71. No, as greater than chlorine. So this will be faster because it's lighter than this one, then this one, then this one. Now, the gas G diffuses slower than methane but faster than oxygen. Okay, slower than methane, faster than oxygen. What can you say about relative molecular mass of G? So G, if it diffuses slower than methane, so the G should be about the relative molecular masses. G should be less than methane, should be lighter than methane, okay, and it should be slower, so it should be greater than methane. So G should be greater than methane because it diffuses slower than methane, should be greater than, and than methane because lower than, and less than oxygen, faster than oxygen, less than oxygen. G less than oxygen. So we can group it like that. G greater than CH4, less than O2. So we can do it like that. This is okay. It should be greater than methane because it is faster. It's lower than methane, and it should be less than oxygen. Why? Because it's faster than oxygen, so the mass would be less than oxygen. Slower than methane, so greater than methane. So this is the answer. Now look at this question now. Complete the paragraph with the words given here. Kinetic model. Kinetic model states that in a liquid and in A are constantly moving. Kinetic model states that particles in a liquid, so we can remove this. Particles in a liquid and in a gas. In a gas, correct? Are constantly moving. In a gas, the particles are far apart from each other and the movement is said to be, do we have random here? Yes, to be random. Okay, and the movement is said to be random. If not good, okay, we can remove it and do it again. The particle in a solid are held in a fixed position in a regular, do we have pattern here? Regular lattice. Pattern or lattice. In a solid, the particles can only vibrate. Do we have vibrate here? Okay. Vibrate about a fixed position. Okay. Liquids and gases or fluid. When particles move in a fluid, they collide with each other. When they collide, they bounce off each other in when they collide, they bounce off each other in different direction. In different direction. If two gases or liquid mix, if you mix two gases or mix two liquid, the different types of particles spread out. Okay, spread out and get mixed up. This is called diffusion. No, diffusion. Okay, this is called diffusion. Now let's look at this. In the gases at the same temperature, do we have a temperature here? Yes, temperature. In a gas at the same temperature, particles have lower mass, move faster than particles have higher mass. This means that the lighter particles spread and mix more quickly. The lighter particles are said to diffuse faster than the heavier. When particles diffuse, the rate at which they do so is the rate they diffuse is inversely related to the rate inversely related to the relative molecular mass. Okay, this is how this we finish now with diffusion with kinetic particle theory. So you can